Good afternoon, everyone. My name is Julie Bloomquist. I'm one of the co-chairs for the SQL Server and Business Intelligence User Group. I wanted to welcome you to our lecture today, Performance Tuning Tales from the Field, and we have Jonathan Fite giving the presentation. Upcoming, we have Data Modeling for Healthcare, Power BI. Morali did part 1 last month, so this is going to be part 2. Here are some upcoming Data Saturdays and SQL Saturday. These are one-day mini conferences. Some are still being held online and some are in person. We have some job opportunities again over here at Save a Lot. Gary, did you want to talk about it?
Sure, and if you wouldn't mind present, I think you want to share your screen. Save a Lot currently has several openings. They are for in the data analytics field. So there's a senior data analytics engineer, which is they are primarily a Microsoft. They're on the Microsoft data analytics platform. So this is Power BI. Someone with Power BI experience. They have a senior data management specialist and a data management specialist position open as well. Those positions are more around aligning the data analytics solutions to specific customers within the business. Similar to most closely aligned with, I would say, a business analyst position, but also quite technical as well. Those positions, I have been a consultant at Save a Lot, and this team is led by Dawn Coyle, and she's fantastic to work for. And the team has been growing. I think there's maybe 20 people on that team now, and it's a great opportunity. So if you're interested, go out to the career portal at dayforcehcm.com and check it out. Don't sleep on it. Thank you.
Okay, so you can see my screen now, right?
Yes.
All right, so here, let me just back up and this is today's presentation. This is, so April 12th, we're gonna have Morali's part 2. And then here's the slide on the Data Saturdays with the dates. Again, here's the job opportunities. And this is all about today's presentation from Jonathan. And my favorite part was, for those who didn't catch it on the emails that were being sent, you know, he's this wonderful senior database administrator. In his spare time, he enjoys the baking bread, hiking, and taking outdoor photographs, but he's also the father of 2 young children. So the prior sentence is only true in the past tense. So I just thought that was a terrific sense of humor there. But he'll get back to baking and hiking and photography. Well, right now you're just probably taking photographs of the kids. So I'm going to stop sharing, and Jonathan, you can present.
There we go. All right, I believe you guys can now see my title slide, and the kids are old enough now. Sometimes they take pictures themselves. They steal the camera, they steal the phone, and just snap away. So I get a lot of pictures of the ground, but nonetheless.
That's great. So we do have the chat feature open, so you should be able to put in chat your questions, and then Jonathan may take breaks, or we'll ask at the end for the questions. So thanks again.
You're welcome. And I'll try to remember to stop at various in between major sections, and we can ask any questions at that time in between. All right. So This is Performance Tuning Tales from the Field. My name is Jonathan Fite. I've been doing database administration for over 15 years now. My current position is Senior Database Administrator for a company called ALC Schools, and they provide alternative transportation solutions for school districts for their special needs kids or edge case transportation, that sort of thing. As a result of that, we face a lot of the challenges that Uber faces, where you're tracking specific drivers and routing and just tons and tons of activity. So I have a very high performance transactional database system that's running on Azure managed instances right now. Just truly just mind-boggling the number of transactions that are going through our system at a time, which leads to the usual performance challenges. You know, how do you tune this so that we can continue to grow the business without outlaying more capital for more expensive cores and all of that fun stuff? So there we go. Next slide. So some stuff, and I apologize. This is missing the two stories that I have at the end for that, but this is what we're going to talk about today. So why are you going to do performance tuning? Your application has to perform the transactions that it needs to in a reasonable time for the users to do it, but management needs their reports, and they don't want these processes to interfere with each other. Of course, you don't want to spend any more money, or you can't afford more hardware or licensing costs for the extra cores. I personally love it for the warm and fuzzy that you get when you fix something that's broken. And then, of course, you get to take that process and you go like, so that process that used to take 9 hours, I turned it into a 90-second query that runs. And then I had to spend 2 days proving that the outputs were identical across both. My typical when I tune a procedure, I typically get about 90% improvement over the old method to the new method, usually in the terms of logical reads or query duration. As with any project, you need to measure your success. If you can't do this and you can't go to the business and explain why it's important to pay down some of that technical debt. So if I go to them and say, listen, if you let me spend the day or two that it's going to take me to tune this and get it tested, then we can do 10 times the number of prior transactions on the same hardware, or at the very least keep us from needing to buy new hardware. So, but I have to measure that qualitatively and say, this is what I have been spending my time on. This is why it's worth it. Usual metrics I use, my gold standard is logical reads. For me, if I can get a query to reduce the number of logical reads, that translates to better query time, better usage of resources, fewer memory requirements to run the query. On the other side of that, of course, is you have happier users if that report runs instantly or near instantly. Then that's a definite easy win. And I want to take this time to shout out about Statistics Parser. If you've ever run your queries with Statistics IO or time on, and you get that messy output, especially if it's a very long multi-statement stored procedure, Statistics Parser can take that text output and will summarize it for you at the end. So you can quickly scroll to the bottom and see the cumulative number of logical reads, scans, seeks, execution time based on that without having to total them up yourselves. So the first thing is, of course, you need to know your environment. You need to know what your server settings are, the memory, the max degrees of parallelism, what your cost threshold is. Make sure you're following best practices. I don't have any real advice for this. except that if you're using full text indexing, don't change max DOP to 1. We did this in our managed instance. We were having some issues with queries just going parallel all over the place. And so we were like, let's change max DOP to 1. We did that, and then our full text index service just sort of died, freaked out, I don't know, but it started blocking everything, and nothing would work. It was pretty incredible. And since it was a managed instance, you're looking online, and you're like, okay, so what do you do to fix that? And you're like, oh, well, restart the full text daemon. You can't. There's no way to restart the full text daemon. It's not a separate process that you can control. So fortunately, we had a failover group, and so we just failed back into the other region. But yeah. Next thing, keep apprised of your hardware, of course, and then the last thing is what's in your buffer pool. And I have, as part of this, I have a script that I'll send out to Julie so that they can, when they distribute the presentation, they can include it. It's a script that will examine what's in your buffer pool and then tell you, it'll say, this table or this index, and then describe how much of a percentage of your buffer pool is this table, that sort of thing. It's really nice if you have PLE, specifically like in my environment, which is hugely fluctuating. So our PLE is incredibly low on 500 on the low end. But by knowing what's in it, I know which tables I need to pay more attention to. And then I can focus my tuning efforts around processes that involve those tables. All right. Next thing is, what are you going to tune and how should you prioritize? I usually listen to whoever's screaming the loudest. If a user is complaining about a process, it's an easy win to improve that process and show value. If a report process is taking forever, especially if you can describe an exact cost to why it's taking forever and why that's a problem, that's another easy win. Then I usually look at if there's any active blocking that's going on that you can catch or deadlocks, then usually focus around those processes. And after that, break out your trusty monitoring tools, sort the queries that are going on by logical reads. Again, that's my favorite metric to use. Like I said, it directly translates to better, more efficient memory and CPU utilization. And then you want to look at, and I usually sort these by the 3 different ones, and sometimes it'll appear in the same different lists multiple times, that same procedure or query. And if that's the case, then it's a winner. And then prioritizing, try and avoid anything that requires an app change. You want to try and be as transparent as possible to the application so it doesn't need to know about the change. So that almost always loses when it requires an app change. But sometimes they have to. For example, if in our case we have entity framework all running just all over the place. And one of the worst queries is just an entity framework monstrosity that 400 columns wide, 200 columns deep, constantly triggers async network I/O. It's just nasty. I've been fighting with the developers to tune that for 6 months now. So not an easy win, but do what you can. So my approach to tuning queries: take the code, and you'll check it for smells, any smells or opportunities. I have details on the next slide, of course. For that, you gather your existing stats because you need an accurate before picture of how it behaves. And then I usually just throw out the query that's there and rewrite it from scratch. After, of course, understanding what it does, to making sure that I can duplicate the inputs and outputs. But I find it's faster just to rewrite it than to try and tune one specific place. Then I usually test it with new stats, see how far I've managed to get. If I've gotten to a good place with it, I usually stop there. Otherwise, indexes and query hints. The query hints that I typically use are max DOP. In our environment, because of the highly transactional single record at a time, parallelism kills us. The table sizes that it's using are not even, and so a parallelism weight usually indicates that I'm burning threads for no real benefit. It's not going to make the query go faster, and it doesn't reduce resources. It just holds threads open. So most of the time when I see a parallelism weight, I usually just add in a max DOP 1 hint at the end, making sure it runs in single thread. So what smells? I've inherited this database. It's not terrible, but it has suffered from having multiple people working on it. So if I see use of functions or unusual joins, anything other than an inner or an outer join, it's cause to examine it more carefully. If you see a where clause that has 5 levels of nested ands and ors, the same table with multiple references, that usually indicates an opportunity to take those multiple references, gather that data once into a temp table or a CTE, and then use that there. If the reference tables are one of the bad ones, again, from looking at my buffer pool, I know the 2 tables specifically that are bad in my environment, and any time that I see a join on those, it almost always goes badly. It starts doing scans instead of seeks, even though the seek is the better operation, just from the memory grant that the system's trying to provide to it. It just starts tipping over and doing bad things. If the query is doing too much in a single statement, you have this huge statement with 10 tables being joined on, maybe breaking it up into pieces would be a better approach. Or the use of group by, because they heard once that distinct was a bad thing. So they just throw group by at the end to get the same effect. Basically, they've not taken the time to evaluate why their results are more than one's, and they need to. And then I look for other opportunities. Our system was built long before StringAg came into existence, so before 2016. And so there's a lot of code that develops a string delimited list using the XML method. And StringAg is much faster, or at least prettier than that XML method. And then reduce any lookups that you can. Are there any questions at this point? I think we've hit the next slide changes tax a little bit.
No, I'm not seeing any questions in the chat.
Okay. So the next couple of slides are talking about new patterns that I've started using in order to solve certain problems. This one is comparing values between left and right, and you've seen everybody's done this or something close to it, but the one at the end is the one I really like. But we're going to start off with the first one, which is you've been given this value, test value, and you want to find any rows where it's different than the key value. So you're like, okay, so a straight inequality. And this is something everybody's done their first time in their career, but of course, it avoids the whole fact that there might be nulls. So you do this. You add in where the key value is null or where it's unequal. And you start paying the price for these or statements. The engine starts going kind of a little crazy when it starts seeing those. Because now the next one is, well, what if test value is null? Okay, so let's add in another one. And we've added another or, and this starts getting complicated, hard to track. And you're like, okay, well, we can simplify this a little bit. Let's coalesce the values. These are strings, so we can just coalesce to an empty string instead of null and compare them that way. Well, that's great, but what if an empty string is a valid value? How do you still compare the difference between these two when either or both can be null, and you want to know? And that's where this last pattern here, it looks complicated, but I really love it. I found it on Stack Overflow. That's one of my hobbies is cruising Stack Overflow, trying to answer questions before people who are faster on the draw get to them anyways. And in there, I stumbled across this pattern. And it's inside here, you're comparing A to B, and then B to A, and then is null. And if they're not null, then the values are different. And if it is null, then the values are the same. And I really like this because it ignores it doesn't need to know a specific data type. You don't need to have a good default value. It handles whether the values are null or not null. It's just straight single line. Null if and is null are, of course, highly optimized SQL Server internals. So they perform extraordinarily quickly, these operators. And it's just something I really like using. And then comparing columns. This is another pattern I picked up off of Stack Overflow. Although if you're using Azure DB or managed instances, or if you're going to be using SQL 2022, you get these two functions, greater and least, finally, for comparing two in-row values and finding the lowest value. Otherwise, this top one, where you're basically selecting the min from values, is the next best one that I've seen.
Jonathan, before you go ahead,
Sure.
on your first example with the null if null, is null, there was a question, what is the performance difference in using the is null null if versus coalesce, especially when the transactional data gets really big?
I think that would boil down to the difference between is null and coalesce in general. Is null is just a highly optimized version of coalesce. If you're using SQL Server, I would argue that you should use is null if you can. But if you want your code to be portable, or if you're in a different database, then coalesce would be the one to use.
Sorry, again, it could be the difference between the last method versus even like the third method that you have up here. I'm not sure if you were able to test any performance differences, both in like logical reads or just the time that it takes to do the search.
I've found most of my queries in the testing is, like I said, for singleton results, or at the very least small numbers of rows. I usually don't have one of these in isolation where I'm doing just one comparison. I usually use this pattern when I'm comparing, on a merge statement where I have a source and a target, and I'm saying I only want to do this operation if any of these are actually different, and I'll list out 5 or 6 columns at a time, or 5 or 6 columns that need to be compared. And in that case, the being able to make it legible has a high value, and so I like that. That's why I like just being able to do the is null, null if pattern.
Yeah.
As far as the performance goes, I've not found any detriment to it, but against having like stacks of say 15 or statements, I think there's quite a bit of benefit there.
Okay, got it. Thanks.
You're welcome. And of course, if you know that your data is not null, then it simplifies it quite a bit. If you know that. This is another pattern. If you're not familiar with the from values, it's one of the ways I think it might be exclusive to SQL Server, where you can generate a virtual table as the where clause. I've done this as a way of getting a string delimited list of reasons. So examining a table, and you're like, why aren't these drivers able to drive for us? And going through and just making up a string delimited list of all of the reasons why they can't drive. So using the from values is, I just think, really cool. So I finally did it. I was able to use a filtered index in production. I found a good use case. It solved the problem, and it was the right thing to do for that solution. And I'm always happy when I'm able to finally use one of these new features, especially since I had never really found a place before now to use a filtered index. Anybody who's attempted to use one or has read about them, you know that they are incredibly difficult to get the engine to actually use the filtered index. All right, so let's see. The story. So we had a table full of, for example, every trip in our system was on this table, and they all had various states. This query was supposed to find any trip that had occurred in the past and was not the completed state, and then set that to this new completed state. There could be hundreds in there at a time, but it was supposed to work on just the top 20 that it could find. So the where clause for it was basically where the trip had occurred in the past and where the state was not one of the states that we wanted. This is perfect for a filtered index. You have a huge set, but the active set, the ones that are not in the completed state, is very small in proportion, a few percentage points. So a filtered index may contain 2,000 rows, whereas the source table may contain 3 million. And so being able to look in just that narrow one is much better. The size of the index is much smaller than just having an index on the relevant columns. So the reason to use from value as opposed to for XML and stuff, I'm sorry. Well, I'll address that after I finish this. After I finish this slide. So a filtered index would be much more efficient as far as memory usage. So at the same time, we had significant blocking with this procedure where it was the root cause blocker for other processes trying to access the same table. And so making this go faster was the most efficient way to make all the blocking go away. So Of course, the way to create a filtered index is you just add a where clause when you're defining your index. Create the index on table, key list, include the additional columns where you're conditional, and then any other index options that you want. The tricky thing, of course, is that it must be deterministic. So you can't, for example, say, show me all the records where the created time is less than today. That won't work. So you have to have deterministic. The other hard part, of course, is getting the query to use the index. And the ways to do that is you can use an index hint, which is my preferred method for this. If you're going to the trouble of creating a filtered index, then you want to make sure it's actually going to be used. So in this case, making your code a little brittle by adding hints is perfectly acceptable, especially if you comment, both where you're using it and in our project. I've commented that this index is specifically meant for another procedure. Hopefully, so that whoever comes after me won't forget to change both places. The other thing is to make sure that your columns that you're in the where clause are in the same order as the where clause in the filtered index. You want it to line up as much as possible so that the engine will use the filtered index. My stats for this and before and after, I went from 795 logical reads per operation to 240. And I went from 240 milliseconds to 3 milliseconds per operation. A massive win, and the blocking went away, which of course sped up the rest of the system. All right, so question was any reason to use from value instead of for XML and stuff? So the for XML and stuff is the XML method of creating a comma delimited list. I'm sure everybody's used or seen that example in Stack Overflow. And before StringAg, it was one of the best pure T-SQL methods for generating a comma delimited list. I don't like using that method because it operates more like a standard correlated subquery. And using the from values, I think, performs better. It also looks a little cleaner in there. So that's my personal. As far as my performance tuning methods in my environment, I don't usually make that change in isolation. If I go through and remove the for XML method and use StringAg instead, I'm taking the time to tune everything in there. If I pick up a piece of code, I always tune it as best I can, because if I'm bothering with it, then I might as well spend the extra time for it.
Got it. Thank you.
You're welcome. All right. This next one is a bit more of a wild ride. A materialized view is a view that has had an index placed upon it, which means that it operates like a real table. It has a real structure in the database with real storage driving it, which means that you can query that specific object without necessarily querying the sub-objects. It can work a little bit like a filtered index, except that you can join in additional tables. You still have some caveats in there, and I'm going to go in there. And a hidden surprise when I was using the materialized view that almost made me rip it back out and go with a different method. But we were able to work around it, fortunately, and we were able to keep it. And I'm really happy because the number of the improvement for this was incredible. So a little bit of background. This is for our mobile device messages, right? So we're sending messages to our drivers using their mobile devices. And we store our messages in this one big table. And side note on message tables and queue tables, don't do them in SQL Server. It's not the right tool for this job. It does it poorly. I have tried to make them go well. I did a whole presentation on queues, and my best suggestion is to just not do it. But back to this specific one. So this is a messages table. And one of the ways that this was designed poorly is that the way you would check for messages is you would look at the message table and see if there are any messages for you that meet any other criteria. So all of your messages are in this one big table, billions of rows tall now at this point in time. Even messages that had long expired were no longer relevant. There was no cleanup process. There was no flag to check to see, is there a message waiting for me? That would be an easy, bit check. The only way to find out was to go to this table and scrape it. We additionally have tons of drivers. The device is supposed to check for messages every 45 seconds. In reality, it's closer to 5 times a minute. So times are, 2,000 active drivers times 5 checks per minute. And this procedure easily crept into the top 10% of our server utilization in terms of CPU, just based on pure execution count. The actual performance of this procedure was actually really good. 50 milliseconds, 30 logical reads. It was the scale at which it was trying to operate that was killing it, or making it be in the top 10. So I took a stab at improving it. In addition to poor logic for detecting your messages, you had to join on to several other tables to make sense of all of the various enumerations that were in the on your message. So your message metadata, how it was sent, the priority with it, all of that had to be looked up in the second in these other tables. So just terrible, just awful. But a materialized view seemed to be the ideal solution. It was another one of those ones where once I created the view, even though I couldn't include date math in the view, because of the same reasons, it has to be deterministic functions only. The number of records in the view was a few thousand versus the near billions that we had in the table. And so this seemed like a justifiable use for the extra cost of writing messages. So the way you create a materialized view is you create the view with schema binding. And all that does is prevent modifying the base objects without undoing this view. So it just sort of locks them in place so they can't change on you. And then you create a unique clustered index on the view. And then there, you have a table, a real table. That table will be updated anytime any of the base data changes. So it seems like a great thing. It's sort of an alternative to using triggers because it all happens under the hood, behind the scenes. And it's important when you're doing any of this sort of thing is you also need to keep track of, well, how much does my write cost increase? Because we had more, our writes went up, our write costs went up from 60 to 78 logical reads, but our reads went down from 30 to 2. So massive improvement. Altogether, in a given hour, the old method would involve 16 million reads, and we went down to 2. So it was a good improvement. Really fun. Our procedure dropped completely off of the radar. I can't find it anymore in our system. Definitely doesn't show up on the top 10%. We did need to add a supporting index to one of the base tables because you still want that view, the logic that needs to update that view to run as quickly as possible. And then the hidden surprise, under the hood, the engine uses serializable locks. And that almost killed it. Before we added the supporting index, it was about as fast as it used to be. So the time to update the base views took a little bit longer, but because it was serializable, we were blocking our readers. And so our readers would come along and try and read the record. And even though it wasn't on the messages table, they were being blocked because of references. So that was a big lessons learned for me and our environment on that this involved serializable locks. So be cautious, be aware. And if you're having trouble, if you've used materialized views and you're like, why is there blocking? It seems transitory. If you're able to get a detailed look at it, you'll see that it's actually a serializable lock in there. But fortunately, the tools we use were able to show me what was going on, and I was able to quickly tweak the performance to make it acceptable. So. All right, this is actually my second to last slide. I do want to apologize for not having any demos or any real code. The nature of doing this as a sort of tales from the field means that I'm actually talking about the work I actually do for my company, and I didn't feel right showing code that I had actually tuned. I've used sort of anonymized stories for all of that. And I'm not clever enough to make up examples that need tuning for that. But some random thoughts is on update statements. Make sure that you add a logic to make sure that the update statements only fire if the data will actually be updated. Ideally, you don't want an update statement to do anything if there's nothing to actually write. But updating a record to be the same value has the same cost on generating log records. And so you're incurring additional I/O throughput costs without real benefit to it. Parallelism, at least in my environment, it's never been a good thing to find a bunch of parallel weights. It almost always indicates to us that a query has regressed. Fortunately, the query store, which I encourage everyone to turn on, and some of the newer features on it are looking to be really awesome. But it lets you see those, enforce a prior plan, and then if you can, modify the code to actually just add in the max DOP 1 hint. The next one, volatile data. So one of our tables is a big table describing every trip. It has, 200 columns in it. Lots of them are large text or XML columns, but it also has a tiny little field that's called estimated on-service time, which is basically the estimated arrival time. So every time a driver's GPS updates and their time to destination updates, that increments, 1 minute down, 1 minute down, etc. But what this means is that we have this entire enormous row being lifted up and written several times a minute, just from that alone. And I used to wonder why our PLE, our page life expectancy, was so low. I don't anymore. I know why. It's because of this. We have enormous pages being lifted up and then dropped back down because the row density is so low, and it's just, that's why. So keep your volatile data on a table off to itself. Using compression, if I've not found a place where I can use it in my environment, but I have looked into it. The places that I would like to use it, I can't because, again, I have large data types. My tables are so large, I cannot compress them. Or not the table, but the row is so large that I can't compress them because the page must be able to be decompressed and still fit on a page, so an 8 kilobyte page. And my records don't do that, so I can't use it. The compression, if you've not experimented with it or looked into it, the CPU cost is very low, but the memory benefit you get from it is incredibly high, especially if it's things like lookups, a lookup table. You're able to fit more data into a smaller amount of RAM, and that's what your benefit is. And then finally, queues and message tables just don't. It's not great. They're hard to get to perform at scale or under load, and they're failure states. When you're keeping up with it, everything's great because that's what you've tuned the queries to do. But if for whatever reason the queue fills up, the message table fills up, you've fallen behind, and now your highly optimized query to get next record or get next message starts falling apart because now it's doing a scan instead of a seek. The table changes. It's abysmal. Just don't do it. It's worth the extra money to do it the right way. Use one of the cloud messaging services or one of the other ones that you can host. I think like Rabbit is a great one for if you're doing an on-prem style thing. All right, and we reached the end of the presentation. I have a list of the tools that I personally use and like using. SentryOne, Database Performance Analyzer, Statistics Parser, Poor Man's T-SQL Formatter, Plan Explorer, and of course, the Query Store on your engine. It's free. Turn it on. Use it. A question in chat about if the recommendations for compression. All of my environment is managed instances, and all of these apply to that. I think I/O limitations is even more important as a metric in Azure than it is using an on-prem. On-prem, it's easy to dedicate a SAN to your SQL server. In the cloud, you're not, and it's actually a billable thing. If you're, that's one of the limitations you hit early is if you have a highly transactional system, you cannot get enough I/O throughput. And there's ways to get more that you need to, but you have to pay for it because you pay for storage utilized or tier of storage. And so if you need faster storage, especially on managed instances, you need larger database files to get that equivalent performance.
Got it. Thank you. That's it. Are there any other questions?
I was just going to say most everything I've been working with lately, it's page compression, and we did see a tremendous improvement in the performance, and also it helped with the storage. Yes.
Yeah, you're retrieving less data. You're able to fit more data in memory with what you have. Like I said, I would really have liked to use it, but it would require re-engineering our database to use it where it needs to be used. Anyways.
Sorry, I'm going to quickly ask about the compression again. So,
all right.
Especially in Azure, even though it is compressed while it is stored, when I'm reading a table, because I mean most of our cases, especially where we're trying to read all the fields, not just one or two, to load into a data set and things like that. So that's still, it's from a log perspective, I don't know how it would make a difference when I'm reading all the columns in material. Or I don't know if that's the case, if it is actually in the back end giving a better throughput because I'm reading, even if I'm reading all the columns. Do you know about it? I'm not very sure.
Yeah, it does. It gives you benefit regardless. So the data is compressed on disk, and it stays compressed in memory as the engine pulls it up. So let's say your table is 100 gigabytes in size, and you add compression to it. Well, now it's only 50 gigs. You'll probably get better compression than that, maybe less, but we'll just call it 50. That means that if you're doing a full table scan, you only need 50 gigs of RAM. You only need to pull 50 gigs off of disk instead of 100. So you're pulling less data off of disk. As the data processes through the processing engine, it does get decompressed and used, but it's still stored. The rest of it, the buffer pool, is compressed there. So now you have more memory for other things to be done. Most of us are not CPU bound in our SQL Server environments. We're bound on memory or disk.
Got it. Thank you.
Should Jonathan, you're using the SolarWinds Sentry 1 versus the SolarWinds, oh, you're using both SolarWinds Sentry 1 and DPA?
I am. The cost difference, if you're curious about it, I want to say it was, I think, another $100 or $200 a year to get Database Performance Analyzer on top of our Sentry 1. Your mileage may vary. I'm not a SolarWinds expert, but I know that the cost increase to add DPA was very minimal, and having both really did help. If anybody's looked at New Relic or those types of tools where they monitor an application and you see like, oh, this call, and you can see all of the components of that call. That's what this gives you, but for databases. So you're able to see this stored procedure, and you can see all of the waits that it encountered. So you can see like, oh, it spent a few seconds doing async network I/O, and then it spent a lot of time on a page latch, and then a little bit of time on memory/CPU wait. So it really gives you some insight into how that query performs or what it's doing. Or, which is what I used it for, one of the ways I've used it is I went back and I looked at it and I said, show me everything that's using async network I/O or spending any significant amount of time on that wait, because that's application, right? Almost always the application is doing something terrible that it shouldn't be doing. And that's how I found that terrible query that I've been trying to get them to tune for 6 months. They're actually working on it. Finally, it took time, but they admitted that it was a problem. And so I really like Database Performance Analyzer. It gives you other insight as well. I think it's just a really, really nice tool.
Yeah, I have the DPA on most of my systems, but we just recently need to make a new purchase, and we purchased the Sentry 1 because I think that shows the query information maybe a little bit better than the DPA.
Yeah, DPA focuses, I like to think of it more, it focuses on a specific query or session level detail, whereas Sentry 1 looks at it as the top down. You know, what is your SQL Server doing? And you can see some of the same information in there as well. But if you're looking for things to tune, DPA is invaluable. It turned up, like I said, some of these things it found for me because just from the way it summarizes the data, whereas Century 1 can't really see weights at all. So I like both. I think they're complementary.
So does anybody else have any other questions? You know, feel free to come off mute and ask. Jonathan, I really appreciate your time. I found it very interesting that you just said you start by rewriting the query. It's like you don't necessarily start with the query that you're given. You start with what is it that you're trying to accomplish.
Especially if I found it because I was like, this query does poorly, I'll pretty much look at it and do a rewrite. But if I'm doing, you know, if it's a crisis intervention, right? The system's on fire and we need a fix now, I almost always jump straight to an index, just because it's faster to do an index or check for plan regression. It's faster to do that and prove that that helps and at least get the emergency over. But it depends. Like, a lot of this code was written 10 years ago. And so a lot of times I just look at it as like, we're just going to rewrite this and do better this time around.
That's great. Something that I recently discovered, we have another server where we archive certain very large databases, very large tables from a database, you know, historical information. And the vendor recommended using a cluster column store index. And I mean, it was tremendous. It was like on one table, it was an 80% improvement. And these were, you know, like multiple terabyte tables. Mm-hmm. So it really helped. But then, you know, they reiterated not to do it on the live data table, just over on the archive tables. So
yeah, I think if you're just using that database as an archive or as a lookup, then column store indexes are tremendously helpful.
Well, thank you again for your time and for the presentation. We really appreciate it, and just, you know, remind everybody that our next presentation is going to be April 12th. It's going to be an evening one from 6 to 7:30. And Morelli, who was asking some of the questions earlier, he's going to be giving the presentation on data modeling for the healthcare Power BI. So it's kind of part 2 of his presentation that he did last month. But thank you very much, Jonathan. It was excellent and very well attended, very well received. Oh, wait, is there a question? Oh, Dean was just mentioning in the chat that he thought it was a great presentation as well.
Well, thank you.
Yeah, thanks, Jonathan.
You're welcome.